bromine and mercury are both liquids at room temperature. Okay, then you need to know which elements are gases at room temperature. That is all the noble gases. All the noble gases are gases at room temperature. So you can see I'm making green stars next to them. Are you doing that? Everything I do, you must do. Green stars. There, can you see? They are all gases at room temperature, as well as chlorine, fluorine, oxygen, nitrogen, and hydrogen. So hydrogen, that one, and those ones are all gases at room temperature. So this is all study work. None of this is understanding work. This is all study work. Ntandu, did you make the stars? Kutlana, you as well. All right. So the stars, I'm making a label for myself here at the top. The stars are all gases at 25 degrees Celsius at room temperature. And the rest are all solids. Okay. Then elements in group 1. Group 1 is a column, so we call groups. Those elements, not hydrogen, you can see I'm highlighting everything except hydrogen. They are all called reactive alkali metals. Reactive alkali metals. You're going to need about 5-6 highlighters. No, not that. Highlighters. And the orange? Right. So I made a label at the top. They are called reactive alkali metals. And it is one of these two that we had yesterday that Tsepo almost hurt himself when he got a fright. You didn't? You fell down on the ground. Right, so they are called reactive. What does the word alkali mean to you? What does it refer to? And last year you did reactions and you either got acids or bases. Do you remember that? Acids and bases. So an alkali refers to a base, a type of base. Okay, so it means all of them, when they react with water, they form a base. Alkali metals, they're all metals. Then we have the second group. They are called earth metals. Alkali earth metals. So we have reactive alkali metals and then we have alkali earth metals. They are not that reactive and you find them in most of them in the earth's crust or in soil. Yes?
Is boron the only liquid at temperature?
No, it's definitely not boron. There's boron. You're speaking about bromine. No, mercury is the one that you held yesterday. Right. Then we have all of these there at the bottom. So all of these are considered transition metals or elements. Transition. So it's a transfer to something else. So it's called transition metals. Transition metals. Okay. Then you can see on the periodic table here in front, there's this bold line here. I spoke about this bold step line. Yes? And I said everything to the left of it is? It is, but it's not all that.
Metals.
All metals. Everything to the right of it is all non-metals. In general. Okay, so I want you to take a pen, pencil, highlighter, and we're going to color in that bolded step line. Like that. And everything to the right of it is non-metals. And everything to the left of it is considered metals. Metals and non-metals. Now, we have exceptions there. Exceptions to the rules. Okay? Around this boulder step line, we have something called metalloids or semi-metals or half metals. Okay? And that is the following. Boron, silicon, germanium. Okay, so you can see all except for aluminium. Not aluminium, but other than that, at the top and at the bottom of this, the steps, because there are steps goes. Okay, they are all considered half metals or semi-metals, or metalloids. These ones. Oopsie. They are all considered metalloids or half metals or semi-metals. Okay, so what does that mean? Under certain conditions, they react as metals, and other times they don't. Like, for example, silicon. Silicon does not look like a metal. It is normally like a creamish, whitish color. It doesn't shine. But if you get it in a certain form, it will conduct electricity, like a metal will do. Right. So under certain conditions, they will behave like metals. So they are half metals. Right. Then we have elements in group 17. This one. In group 17. Okay. They are all... Oh, wait. I'll get to their name in a moment. And then we have elements in group 18. Okay. Anyone can remember what do we call elements in group 18? Yes? Noble gases. Noble gases. Okay. Now, what does the word noble mean? If you are a noble someone. Say again? Oh, common. Humble. Yes. Some people use it in that sense, yes. But noble refers to, in my story now, refers to, sorry, when you are like a king or a queen. Okay, so noble, you are part of the noble family, then you are part of the kings and queens of whatever. Right, now, this is just a story in my head. One day, someday, when we are up in heaven, then around the throne of the king will be what? No. Around the kings, around the nobles, there will be what going around the throne?
Guess who's?
Don't say everything Tando is saying. Now, angels around the throne of heaven, yes? And what do angels have on their heads? No, angels, not the king, angels. What do we call those rings? a halo. So around the nobles, we have something that has a halo. And so group 17, that group, the yellow group, is called the halogens. Because they have a halo. They're close to being a king and a queen. Yes.
So then why is the same like highlighted one the same as 18? Is it the same thing?
No, this one is pink and this one is purple. Okay, we're not done yet. Then there are elements we call diatomic molecules. Diatomic molecules. Okay, and I'm going to encircle them with red. So I'm going to encircle them with red. Diatomic molecules. Now, diatomic molecules are molecules that are like twins. Is jy klaar met commercial? Who do you want to ask for highlighter? Alright, so diatomic molecules are like twins. You know, sometimes there's twins that they are inseparable. Like you always see them together. It's like one person. And you just hope and pray that one day, someday when they marry, they will marry two separate people. Like they won't marry one person. Yeah, have you seen twins like that? Alright. So, diatomic molecules are the same. When they are on their own, for example, oxygen, it will never just be O. It will always be O2. It will always be together. Okay? If oxygen bonds with something else, then yes, it can be O2, O1, O3, it doesn't matter. But oxygen on its own is a diatomic molecule. It's always 2, 2, 2, 2. Now, there are 7 of molecules like that. 7 diatomic molecules. It makes a 7 on the periodic table and it starts at element 7. Okay, so it starts at element 7 there. 1, 2, 3. Can you see it makes a 7? Started at element 7, it makes a 7. Now I said how many elements are there? 7. Let's count. 1, 2, 3, 4, 5, 6. Ma'am, where's the 7th one? The 7th one is hydrogen here in the corner at the top. So they are all considered diatomic molecules. Right. Last thing on here. Which of these 111 elements must you know off by heart? Okay, wait, I'll tell you. Thank you. You must know the first 20. From 1 up until 20. You must know the name and the formula. Okay? So you must know elements 1 to 20. As well as the following. Okay, are you all wake up? You must know chrome, so number 24. Number 24, chrome, magnesium, not magnesium, manganese. Manganese, 25. Iron, cobalt, nickel, copper, zinc. Okay, not done yet. And silver, number 47. And gold, number 78. And then also platinum, 78 platinum, 79 gold, 80 mercury, as well as tin, number 50. Encircle it with your pencil, like the rest of us. And lead, 82. And at number 92, there at the bottom 2 rows, number 92, uranium. And then there was two more. We're on the left side, number 38. 38's name is strontium. Do you know what is stront? Shit. I'm recording. So in Afrikaans, it's stront. Anyway, so it's a funny name. Strontium and barium, number 56. Right, so you must know their names, those that we encircled, as well as number 1 to 20, the names and the formulas. Yes. Okay, now, I think they are all easy, like chrome you can sort of get from there, manganese you can sort of get from there, iron, I think you've all used iron a lot, cobalt, nickel, copper, zinc, right, platinum, sort of easy. Now, I used to get confused between silver and gold, so the way I remembered this is if someone asks you to marry them, and you ask with which one is more valuable, silver or gold? Gold is more valuable. All right, so silver will go, it's a softer metal and it will like rub out faster over a few years, where gold will take longer. Okay, so if someone gives you silver, you say, ach, nee. Okay, or if someone proposes with a gold ring, you say, oh, gold. All right, so that is how I used to remind myself which one is which. Ach, nee, silver. Of, ooh, gold. All right, mercury, lead, tin. Tin. SN is tin. All right, and uranium there at the bottom. Okay, so your next speed test will be on the periodic table. Okay? So for your next speed test, I can either ask you what is the name of group 1 elements, or I can ask what do we call, or which group is the halogens. Then you'll say group 17, or you can say group 7. Or I can ask you what is the name of Fe. Okay, or I can ask you let's say, is carbon a diatomic molecule? No. Okay. Or what phase will brome be at room temperature? Liquid. Okay. So you must know the periodic table like that for your next speed test. Okay. Then I'm on page 4. Okay. So page 4 you can see is a lot of theory that you must know. So let's quickly go through it. First we're going to look at the metals. Okay, the metals have some common properties. First of all, most of them are solids at room temperature, except for mercury, which you saw was a liquid, a very heavy liquid. Then metals shine when they are polished. Then they are malleable. What does that mean? They can be formed into different shapes. They are ductile. What does that mean? They can be drawn into wires. They are good conductors of heat and electricity in general, metals. They are strong relative to their density. And they're normally grey in color, except for gold, which is yellowish, and copper, which is pinkish, reddish. Okay, things that you all knew, yes? Nothing here should be new. Because you did study the words malleable and ductile for a speed test. Yes, you did your first speed test. Do you know what a conductor is? Okay. Right. Then non-metals. Non-metals are normally solids or gases at room temperature, except for bromine, which is a yellowish liquid. Then in general, they have lower melting and boiling points than metals, except for diamonds. Have the highest melting point, not boiling point, melting point of 3,500 degrees Celsius. That is very hot. Can you tell me what are diamonds made of? Carbon. Right. Then, in general, non-metals are poor conductors of heat and electricity. They don't conduct that well, in general. Except for graphite is a good conductor of electricity. You find graphite in your pencil tip, right? In the lead of pencil. But what is graphite made out of? Is it made out of lead? No, we call it lead, but there's no lead in there. Pencil is made out of carbon and clay. It depends how soft your pencil tip is. A diamond in the making. That's why they say you can't make diamonds, or for diamonds to be made, you need rough conditions. Because graphite, when it's under a lot of heat and a lot of pressure, it changes into a diamond. So if you want to be a diamond one day, you're going to have to go through trials and tribulations. Right, now, diamonds are made out of carbon. Graphite is made out of carbon. Right, both made out of the same thing, but they're two different things. Like the value of a pencil and the value of a diamond, light years apart. Quickly look, in which group number, will we find carbon? 414, right? Now just look below carbon, you have what? Si. Silicon. Can you remember my first lesson in this chapter? I said silicon is very valuable. We use it in computers, we use it in putty, we use it for glass, it's in sand, it's in blah, 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 blah. So immediately you must start to think, okay, carbon, different uses, silicon, a lot of uses. So everything in group 14 is very valuable. It is a different or wide spectrum of things that we can use it for. Okay. Then lastly, non-metals make brittle solids. Brittle solids. What is brittle again? Hard to the touch and can break easily. And they vary in color. So non-metals, some is yellow, some red, some blue, some white, orange. It's different colors. Okay. Then metalloids or semi-metals. I'm just going to go back to my periodic table. On my periodic table, there I had my metalloids. Okay, we highlighted them there. So, there they give us 7 metalloids. They lie between the metals and the non-metals. They have both metallic and non-metallic properties. So sometimes they act like a metal, sometimes they don't. When do they do what? When they increase in temperature, when it gets warmer and warmer, their conductivity increases as well. So then they conduct better. And this is the opposite to metals, because their conductivity decreases when there's an increase in temperature. And I explained that also in the first lesson. I said silicon we use in digital appliances, because old computers, when you use them for a long time, they become warm, and then the lag, they start to become slow, and you have to hit them a few times. Ne? Whereas new technology, they're better because they have more silicon in them, less metals, and they tend to lag less. So it means the warmer they get, the better they conduct electricity. And then we use semi-metals extensively. Extensively means a lot and in a wide variety in electronics and computers. Alright, we are going to stop there for today.
Sorry,